We've been talking about the mechanics of sound and going over a lot of concepts, so let's start with some equations. It's about that time. So let me give you a quick review. Sound is a longitudinal wave. It's a mechanical wave, and what mechanical waves do is they transfer energy. And for sound, the energy is transferred in air. That is the medium that we use to transfer energy. And here's an example of the data that is collected from sound. I did this for you in class with a tuning fork. And what you're seeing here in the peak is the amount of compression those air molecules have. And to make those compressions, you have to put energy out into the air. And the more energy you put out, the higher your volume is, then the higher these peaks are. You have a lot of power. You have enough power to get your sound further and further away. For sound, we call that intensity. So let me go ahead and define intensity for you. Let me find a blank sheet of paper, if I have one. So let me define intensity for you. Intensity is, for sound, it is the rate at which the power is distributed, but for us, we have to take a look at how and what frame of reference or in what condition that sound is transferred. So let me go ahead and define power. Power. That is the rate at which energy is transferred. ED. Alright, and so power, P, is how much energy is transferred in a certain amount of time. If I have a lot of energy and I can get it out there in a small amount of time, then I have a lot of power. And we're going to call power, we're going to work with power, and the unit for power is watts. W-A-T-T-S, the same thing that's on your light bulb, 60 watt, 30 watt. So power is watts. And so intensity for sound is the measure of loudness, the measure of how much power you can put out there or the source can put out there. So let's say this is my source. I don't know, car horn. The thing about sound is that it travels out in spherical waves. Spherical waves. And I hope you can see that if here is my source and I'm standing here and maybe another classmate is standing here, that I'm going to get a lot of that energy. It is condensed. My circle isn't that big. My sphere isn't that large. So I'm going to get a lot of that energy. And this student is going to get not quite as much because the area in which the sound travels is a lot larger. And so power, when we take a look at intensity, we have to look at the surface area. It's how much energy is traveling through the surface area where my observer is standing. So I is equal to the amount of power, and since power is transferred out in a sphere, we have to look at the sphere, how big that sphere is at the location of where the observer is. And that is actually the equation for the surface area of a sphere. Surface area of a sphere. Alright, so the closer you're in, the smaller the surface area, the more power you're going to get. And as you move further and further away, the power falls off by R squared. So you've worked with inverses before. It falls off. This is called the inverse square law. So let's say a person here is standing at 2 meters and this person is standing at 4 meters. Then the intensity between this person and this person falls off by 1/4. Because this R is 2. If the difference between the source and the observer is 3, then the intensity is decreased by 1/9. And so that's that whole inverse square rule. And we'll see that a little bit more further on when we get into electricity and some other things. So let's take a look at what an equation looks like. I have a sample problem here. Let me find it for you. And it says, what is the intensity of a sound wave produced by a trumpet at a distance of 3 meters when the power output of the trumpet is 0.2 watts? 0.2 watts. So let's see, what is the intensity? What is I? Since I is equal to the power over 4 pi, depending on how far the person is standing, so r squared. Then I can substitute in 0.20 divided by 4 pi, and it's 3.2 meters squared. Remember, we use standard units, so the radius is, since it's a distance, it is in meters. I have my trusty calculator here. Let me plug that in. Let's see, 4 times pi times 3.2 squared. I like to do the bottom first. And that's 128.68, 0.20, 0.2 divided by that number. And I get 0.00155, and that's watts, the unit for power, over meter squared, the unit for your radius. That is the unit for intensity, and that seems rather low, but let me show you a chart of what we can hear, what we can actually hear. So that is, how many decimals? That is 1, 2, 3. That is 3 decimal places, 10 to the negative third, somewhere in that range. That's the power. Take a look at this chart. Here is the various sound levels of intensity. Take a look at the threshold of hearing. The threshold of hearing is way down here, which means that the intensity rating is 0. Let's see, we got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is the intensity level, and that is watts per meter squared, of the minimum sound that we can hear. Compare that to this trumpet. That trumpet is quite loud, 10 to the minus 3. If I look at my chart, 10 to the minus 3 is somewhere around a siren, between a siren and an auto interior moving around 90 kilometers per hour. That's pretty darn loud. Since we can hear at such little power, since our ears are so sensitive that we can pick up this amount of energy in a second, which really vibrates your eardrums back and forth very little. I mean, I've heard it say that it's less than the width of a hair. If your eardrum can move less than a width of a hair, you can hear that. You can detect that. That is the threshold of hearing. And a lot of times, babies have that. And then as you get older and your eardrums start to stiffen and get older, you start to not be able to hear that. Now maybe we can hear a leaf rustling. And then if your hearing gets a little worse, then barely you can hear a whisper. When we get into class, the next time I see you, we are going to turn our intensity levels into what we call a decibel rating. And it is a log base 10 calculation. And I hope you all know how to work with logs. If not, I'm sure I will teach you and we'll go over it in class. So that is an example of intensity level. I hope it's pretty straightforward to you. And when I see you next, we will turn our intensity level into decibels, what that actually means. I think you all are a bit more familiar with a decibel rating and not an intensity level rating. And that's what we will talk about when I see you next. So I hope this was pretty clear. If not, I can answer questions in class.